Good morning, everybody. Happy second day of e-learning. This is Miss Clifton here. I miss you a lot. So I'll get right down to business. I'm going to try to help you through word problems today. Those are kind of tricky. So we're going to finish off the section 8.1 of the book, which is the first half of homework 8.2. And I picked a problem that seemed like it would help you with the other problems. So number 77, not on your homework assignment, but it will help you with the other problems. A train leaves Union Station for Central Station 216 kilometers away. Okay, so that is a distance clue. So I got some distance going on. At 9 a.m. 1 hour later, a train leaves Central Station for Union Station. They meet at noon. Okay, all of that is time clues. So what I do in this situation, when I realize I'm going to have to calculate something with distance and with time, is I make a distance and time chart. Actually, there's three parts to it. It's not just distance and time. Do you know what the third element is that's going to be important? It's what the question asks for. The question asks for the speed of each train. Okay, so what's the relationship between speed, distance, and time? If you think about speed, it's usually measured here in miles per hour. That's a distance divided by a time, miles per hour. So that's what I have to keep in the forefront of my mind as I calculate these. But for the time being, I just think there's a lot of information here. So I'm going to try to keep that information making sense to me by making this little chart. I would suggest you do the same thing. So I'm going to have speed, distance, and time be the columns. I'm going to call the first row train A, because I read ahead and I can tell there's two trains in here, and train B. And the first clue, that first distance clue over here, was that they're 216 kilometers away from each other. So I'm going to fill in something in the distance column here. It's just a matter of what. I'm going to have to create variables as I go, so just be aware of that. So train A's distance plus train B's distance is going to be 216. They're apart from each other, so the distances will add up to that. I want to call train A's distance D. I have no other reason to call it anything else. I'm just going to call it distance, so it helps me keep track of the distance. If we know that train A's distance is D, then how should we say train B's distance? We should say it as 216 minus D. Does that make sense? Okay, so that's how I got my distance column filled out. Great. Next one is time. It says 1 hour later, okay, so we're at 9 a.m. for train A, and then 1 hour later, train B leaves. They meet at noon. So we actually don't need variables for this. That's actually enough information to know the times, right? If one of them left at 9 and got there at noon, and if the other one left an hour later and got there at noon, we got times of 3 hours and 2 hours. If I was being really careful, I'd add hours to this. I'm just going to have it be this way. Okay, so does it tell us anything about their speeds? It just says the speeds are the same, whether you think of it this way or whether you think of it the other way that it's about to propose. So here's what I'm going to do for speed. Excuse my beeping. I'm going to do for speed, I'm just going to say, oh yeah, I know this. Speed is distance divided by time. So I'm just going to say that speed is D over 3. And speed is 216 minus D over 2. If you look at how many variables are in this chart, there's only one variable so far. So the way we did this is not going to be enough to solve. We're going to need to make two equations with two variables. What information did we not record yet? We didn't look at this whole second to last sentence. It said if the second train had started at 9 and the first had started at 10:30, they would still have met at noon. Okay, here's what I want to do for that. I want to extend my table. This doesn't happen every time you do a time distance chart, but this time it is. I want to make another 3 categories for speed, distance, and time. So in this first one, I'm going to say these were all for the original trip that was planned. And then these next 3 are for the new trip that was planned. So speed, distance, time once more. Now it says second train starts at 9 a.m. Second train starts at 9 a.m. and still gets there at noon. Okay, that's 3 hours. First train would start at 10:30 and get there at noon. That's 1.5 hours. Did the distances change? I don't think so. So I think I can still call this D into 16 minus d. So I'm still going to fill in my speed column as the same thing as before. Speed is always distance over time, as we kept at the forefront of our minds by writing at the top of our paper. So we're going to say that's d over 1.5. And we're going to say, wait, did I lose a variable? Oop, we did it wrong. The distance does change. The total distance doesn't change, but we can't use d anymore. D specifically meant the distance of train A to get to where train B was. Well, that's going to be different if they start at different times. So I do have to come up with a new variable here. My mistake for not seeing it at first. Okay, so what variables have I used? I called them train A, train B. I called the distance D. I'm just going to call the distance C. It seems like a variable we haven't used yet. So if it's going from different times and still meeting the other train, these are going to be different distances, but the distances still add up to 216. So that's what remains the same. So we're going to see this as 216 minus C now, okay? All right, so back to the speed being distance over time and the speed being distance over time. Okay, now look at this. We've got two variables. I think we can set this up. Okay, so in the first scenario, the original scenario versus the new scenario, are they supposed to have the same speeds? Well, not as each other. A and B aren't supposed to be the same speeds as each other, but they are supposed to be the same speeds as they were. Like train A doesn't slow down or speed up. It just starts at a new time and still meets at noon. So I'm going to say that train A's speed is supposed to be equal to train A's speed later. D over 3 is supposed to be equal to C over 1.5. That's one equation. Anyone want to guess what the other equation is? Yeah, train B's speed should be equal to train B's speed later. Okay. Do you think that's a solvable system? Have we got two equations? Do they involve two variables? Yeah, you can solve that. Good. So I would let you solve it. I would have you pause this and just check on your own skills, but I can just keep going for you. So I would suggest you solve it, but I'll keep going. All right, so if I want to solve this system, two equations, two variables, I'm not into the whole fraction thing. This is a good time to do cross multiplication. A lot of you try to do it at weird times. This is like the right time when it's one fraction equals one fraction. And that just means if you multiply both sides by the bottom of one of the fractions, it will become the top of the next. So this becomes 1.5d equals 3c. And this becomes, let's bring up my little calculator. Did anybody leave their calculator at school? If so, shoot me a message and I'll try to research how you can get one of these online calculators like I have. So 216, because later in this unit, you will absolutely need a graphing calculator. There will not be a way to do the later parts of this unit without a graphing calculator. Okay, so I got 648 minus 3d equals 432. Does that feel right? I sure hope so. Minus 2c. Okay, so I got rid of the fraction issue. Now, should I use elimination or substitution? You really could use either, actually. I could see an argument for either. I'm going to say substitution for me. So I'm going to substitute, or I'm going to isolate d. D equals, what's 3? Oops. It went away. What's 3c divided by 1.5? It is 2c. So then I can take that 2c and plug it into this d. 648 minus 3 times 2c equals 432 minus 2c. Oh my goodness, it hates me. Okay. I'm getting bored. You should do this without me because you're smart enough to do this yourself. You don't need me to check your work, but I'll still do it because I like you. Okay, so I gotta find out what 648 minus 432 is. 216. Oh, I should have thought of that. Yeah, 216 equals 4c divided by 4. We are going to have c equals 216 divided by 4. 54. Okay, what did c mean? I've entirely forgot by now. That's why I recorded stuff in the chart, so that I would know what it meant when it was time to finalize my answers. Okay, so c was 54. That was the distance on the second trip. Is that what they asked for, the distance of train A on the new trip? No, they asked for the speed of each train. So I've got to finalize this by knowing what the speed is. Oh yeah, c is 54. So all I'm going to do is do that the speed is 54 over 1.5. And then if I do that in my calculator, 54, stop emails, 54 over 1.5, I get 36. So that means the speed of train A on the second trip was 36. Now, in theory, that should be the same as the first trip. Now we can figure out the speed of train B on either trip as well. So that was 216 minus c over 3. We now know that c is 54. So 216 minus 54. 162. That number divided by 3. 54. Oh, that's kind of funny. All right, checking my answer. Yep, I have the answers here, and those are the ones we were supposed to get in the back of the book. Kilometers per hour, kilometers per hour. Okay, now you've seen one full problem all the way through. They are tricky. Do your best on these. How many problems did I assign to you today? 1, 2, 3, 4, 5. 5 problems. Okay, stay safe. Listen to your parents. Have a nice time. Bye, guys.